All right, we are live. Just waiting for Instagram to come online. All right, we are on Instagram and everywhere. Okay, welcome to the stream number 2 in this series. And seems to me that there is a problem on Twitch, but let me see. No problem. It's okay. Fine. So, welcome to the stream number 2 in this series. And in this series, what we are doing is we are, first of all, to give you the background, we were able to run Flux very well on different scenarios and generate a lot of images. But what I realized was that running Flux on A100 instances is just not practical. So, and it needs a lot of GPU, and especially also I wanted to introduce another model, that is control net. And control net would be another problem because control net itself is like 6 GB, 3 GB, 4 GB of VRAM usage. So definitely I needed to make some changes to the pipeline so that we can keep generating images with higher and higher quality without burning a hole in the pocket. So that was the last stream and the first stream in this series, where we tried to solve that problem, and it was getting very difficult because most of the models that we have are like GG UF or some format like that, which is good for Comfy UI but not good for notebooks and notepads, wherein you are just dealing with stable diffusion pipeline, the diffusion pipeline, right? So that is the problem, and the solution I figured out and just wanted to share with you. I have also created a post on my blog, which is the desiloops.com, where you can see the post which talks about how you can also run now Flux with ControlNet on free Google Colab subscription. So you don't have to pay, but I'll just share my findings and my feedback also. So let's, without further delay, let's get started. All right, just a second and I'll be on. Okay, now I'm talking to the code camera. Let's get started. So this is the notebook which I'm working with, and it's also available. You can just go to desiloops.com, which is my blog, and I have created this running Flux one dev with ControlNet on free Google Colab. Here you can download this notepad notebook here, and it is the same notebook that I'm working with. There is nothing that we are going to. If something happens, I'll update this document, so you can always get the latest copy all the time. All right, so let's break this down a bit. First of all, a huge shout out to this guy, whoever has done this repository and this model, which does quite a good job because it does 4-bit quantization of Flux 1 dev. And I did not want to step away from Flux 1 dev because I have trained a lot of LoRa's on it. So, that was one thing. And quantized BNB is not as good as HQQ 4-bit and Flux transmit. Okay, so I haven't read the rationale behind this model, but I just wanted to save VRAM, which was like my biggest concern, because I don't want to pay like $1, $1.50 an hour of working with Flux, wherein I'm just exploring the art and the a lot of times with Flux what you end up getting is a lot of time with Flux what you end up getting is like you can generate a very basic image very very quickly, but the problem happens when you want to generate the higher quality images, and it takes a lot of time to work with the prompt and get things right. And for that time, to pay like $1.50 an hour, which is very very expensive, Google Colab just gives you like for a, I think for the paid version they give you around 100 compute units a month, and 800 takes like 11 per hour. so you cannot. It was not practical, anyways. So I have decided to do that, and yeah, huge shout out to this guy, whoever has done this model. Excellent job. Library on 16 GB GPU. All right. So, and also this is like, one huge thing is you can train new LoRa's very, very quickly without, burning a hole in your pocket, because training a LoRa takes like 1 hour, 1.5 hour easily, a good LoRa. And yeah, don't want to pay that much money, we can definitely use this one. Uh, so yeah, if you see, if you take, even if you put the whole pipeline on GPU, then it consumes 11 GB of VRAM, which is not kind of true. I mean, like, but still, it was kind of true in my testing, and I'll get more into this when I'm showing you the notebook. But just a second, my lighting was messed up. Now I think it's better. All right, so what I wanted to show was that okay, so it's that, you can put the whole pipeline on GPU and still get like, good headroom on a decent GPU. So in Flux, in this one you have Google Colab, you have these different types of runtime. A100 is the most expensive one, we have already discussed, like takes around 10, 11 compute unit uh, an hour. So for 1 month of normal, like, paid version or whatever, you are paying way too much. So then the next one is L4 GPU. We all know this one, which is quite good. It gives you 24 GB. On Colab, I don't know, for some reason it says 22 GB VRAM. So that, and then T4, which is also available in free. So that's another huge benefit, right? You can always use the free version, like even if your subscription is expired, you can still use these GPUs and do your work in some ways, right? Which has 16 GB of VRAM. And then yeah, this one TPU not useful for TensorFlow, not useful for PyTorch models, which is essentially what we work with day in day out. So yeah, that's where we are. uh, just a second. So that's good. And if I show you, so I'm all running the free one, which is charging like 1 compute unit an hour. And you can see that when I generated an image, which is this image, and why this image, if you ask me, because also I'm using a control net. Now, control net, if you see here, and if you don't know control net, I can tell you very, very quickly. In control net, you can control the image generation process to a great extent by doing a lot of kind of customization. First of all, by defining these sort of outlines, and there are libraries which can take normal image and give you these outlines, and you can do whatever. For example, if you have an image, right, you can, even using a depth map, you can do blurring, you can style transfers is another thing, right? So you have an image like this, you generate an outline like this, and then you can generate like comics, whatever you want to do, whatever you want to generate. The next one is definitely poses is also very, very important, because when you want to say generate images in certain poses, certain designs, definitely, that would be very, very handy. And this pipeline, which is control net union, is about 6 GB. And during inference, it's probably going to be living on your GPU. So that would have been also a problem with going with 8100. Maybe it would have worked fine, because A100 has like huge, like 48 GB RAM. But and also during my testing, I have seen maximum like 20 GB being used during the inferences, even if it's certain custom LoRa's. So I would say another, like, if you're using this control net, you would be probably using around 30 GB. But still, A100 is too expensive. So yeah, coming to this, we are using this control net in this notebook, and that's why I use this Canny image, which comes by default. And I think I have shown it in the previous live stream also. So we have this, like, control image, and we pass this to the control net, and control net generates this, which is quite good. I mean, there is a little bit of variance, and that variance is probably due to how we are using the control net pipeline. So there is a control net pipeline which is somewhere, I think I can just show you. So very quickly, just whenever you get a chance, have a look at this notebook. But what we have is we are cloning this repository, setting like seeding into the directory and stuff like that, basic stuff like we do requirement.txt installation. We take the Hugging Face diffusers directly from GitHub because the latest version of diffusers is not online yet. And then we have got like we run this model.py, and then yeah, we do the setup. Now this is what I was talking about, and that's why we have to use the latest model from the GitHub. Is because latest Hugging Face diffuser library from GitHub is by going to Flux control net pipeline. We want this one, and if you see this one is very very good because you see here, there it is. Probably this is what we want. Control net with Flux one diffuser pipeline, Kenny depth, and all of that. But I probably don't want like this, but that's okay-ish. I don't. I wanted to look at the node, like the documentation from here, because they have an example, and it's very very useful. So here you can see guidance scale, which is the prompt guidance scale, prompt control net, and control net conditioning scale. This is what the variable is, and it has. This is an interesting variable. I'll just share what it does in a moment. Default to 1. The output of the control net are multiplied by control net conditioning scale before they are added to the recipe in the original unit. If multiple control nets present in it, you need to. I think this is what I mean to say was, you have this control net somewhere, you know, maybe they have. What I wanted to share was, see, if you see this image and the image that I was showing you, which is this one, there's a little bit of variance, right? You can see that the hair is not exactly where they are here, and the pose like head is little bit more turned towards the camera compared to this control image. And there is a parameter that allows you to control up to what degree of freedom you want to give to the model. So model here is not like fully stuck to uh, model is not fully stuck to the control net image. But let's see, what I wanted to share with you was, uh, let's see, this one control net. Now here, probably there is a documentation somewhere where it tells us how the control net conditioning scale. I think this is the one, and probably this is the one that I was showing here as well. Conditioning scale, yeah. So default, it said was, what is the default value that we are dealing with? Control net defaults to 1. The output of the control net is completed multiplied by scale before they are added. Okay. It doesn't give me too much. I just wanted to look at that particular one because I don't know if it is a scale which you can start from 0 and go to 1. But again, let me come back to this. First, let's get this out of the way. We are using the free GPU instance, and we are able to generate these beautiful images while the same time not consuming like over consuming RAM, not getting code out of memory errors and things like that. And in this particular case, I'm using CPU offloading. So probably that's why the generation speed is very very slow. So that is the catch. So if you're using the free Colab instance, the images are going to take forever to generate. Like here, it took like 13 minutes. But if I had it on a, like if I had it on a decent system, then the image generation was fine. Like when I still not burning a huge hole in the pocket. Like if I go for L4 GPU, which is a nice one, which has like 24 GB RAM, VRAM, then it's fine, and it gives me like 30, sorry, 3 compute unit per hour. So still about 3 and 4 times less expensive than your standard A100, which is nice. So it gives you some breathing room when you're doing this whatever project that you are working with. Let's set this up while we are on this uh, call, and meanwhile I'll just show you what the conditioning scale was. So Kenny, I think probably here we saw. Yeah, here you can see. What you see is that you have this can image. As you increase the weight, you can see that the image is respecting it a lot. The can image. The prompt and also is also important. Like Colin City, 25 years old, cool, futuristic. So this prompt is kind of important, I believe. Uh, and we'll probably use this prompt because I'm actually using one prompt from one design and then doing it here or something. I don't remember now where I'm getting the prompt from. Anyways, so we have done this. I don't know why CD is probably a unnecessary one. I may have to remove it from all the tutorials. We need to do requirement or TST. One, good thing to know is this will take some time, especially this HQQ takes some time to basically install itself. So yeah, that's a heads up again. Now let me just go break this and use this fuel futuristic. Now we'll just start with a simple image and scale. Control net scale is 0.5 right now. Okay, so that makes some sense actually. So while we were getting this much freedom in this image, let me save this image just for these things, and let me go and create a new folder for this image to image. I'll create a new folder here somewhere, and we'll say control net and new folder again, output. Save this like 0.5 any control scale. Now let's see, is it installed? Now you can see, right, it takes time. It's not going to be fast, but I still don't mind because yeah, because I wanted the freedom to explore Flux properly, and how to generate really good artwork out of this, and not just any artwork, like artwork that can be used to solve real world problems. And that's why I wanted to get to a state where I can play around with the model as much as I want, and basically, yeah, basically not have to sell a kidney or something. So yeah, I think things are moving here. All right, just give me a moment. Okay, we are very very close to having this working. All right, so this is installed. Gives you some idea. It took like 2 minutes. I mean, 2 minutes in Google Colab seems like eternity because you are paying per hour. So that's not nothing. Probably on local computer also it will not be a big issue. And now we can run it on local machines as well. If you have like any decent sort of GPU or like Mac M1, M2, probably you can do it. Maybe with Comfy UI, anyways, you could have done it. But I don't know Comfy UI, and maybe I should probably explore that in one of the future streams. Drop me a message if you think that we should do that. Right now, where are we? We have done that. Let's import all the libraries. Let's import all these packages, which take a bit of time. Another thing, if you see why are we doing running this model.py, because this repository, I think, changes the models a little bit, especially those two models that we are dealing with, T5 encoder and Flux transform 2D model. I don't know exactly what changes are there in this library. Maybe it will be a good idea to have a look. But if we have to, right? I mean, like at this moment, that's not something that I want to do. Um, but yeah, here it is. I mean, like unused keyword arcs, not used in class, blah blah. I don't know why these things are defined, right? But we are getting the results, so I'm not complaining. But yeah, that's where we are. All right, let's hope for the model gets. Hope that model gets ready. Meanwhile, let's have a look at how the control net scale parameter works, because I don't think we see it properly. Open image in a new tab, maybe. All right, so you can probably see how it works is you start with this image and you set the weight 0. Then the image is completely generated using the prompt. But as you set up and increase the scale, the control net actually takes over the image generation and generates exactly everything within the control parameters, right? About 0. 0.7 is what they have shown. Maybe after some model will collapse, maybe it won't. We don't know. So almost done. Most of the things are getting ready. You see the GPU is used is like less 8.5 right now. So I am going to move everything to CUDA because then I mean, like, I don't think it's that execution difference if you, even if you move everything to CUDA. But you can see now we are consuming 15.4, which is not like really high. We still have a lot of headroom in the GPU. Now let's generate this with a higher control scale, like maybe 0. 0.7, and see what, like, how much of the image thing we are getting. We have to, like, I'm doing 36 steps, which is kind of little bit high from whatever we are seeing, but it's fine. So now we are, while generating, we are using 17.1 because probably it's using control net now, and just all the all the PyTorch variables are up now and they're activated. So all the neural networks and layers are activated, and this is where we are, like 17.1. Not bad. Uh, Still a lot of room to go, and probably this will be, like, the upper limit of all the image generation. So from here you can do whatever you want to do, and you can see that the image generation is super fast, like 36. Doesn't even take too long, like it took like less than a minute. And so I would say, yeah, this would be a great choice, like L4 with 22.5 GB RAM, VRAM, and you're good. Let's see how's the image working. Okay, so now you can see that it is kind of doing a bit of like realistic style, ray traced female travel. I think the let me go back here to see the effect. And if you see, right, as you get closer and closer, the output becomes very much like, cartoonish, from realistic to cartoonish. I don't know why it happens, but they say ray traced female blogger, whatever. But now, if you see, save image as and save this while we download the Canny image once again, or just have a look at this Canny image here. So if you see that there's not much freedom now, it's doing exactly what we want with this model. So probably 0.5, 0.6 is a good idea. Like if you're generating something while maintaining a lot of things, messy beach waves, realistic. I am not able to control this image style too much. Uh, Photorealistic, maybe. Photorealistic. Photorealistic. Let's see, photorealistic, uh, cinematic shot. Um, those two are should be good. Spelling is not correct. So this is another thing that I was thinking yesterday, that if you are using prompts, right, the spell checking is super important. Maybe they are using some sort of like text encoders which kind of map it to the can take care of the spelling mistakes and all. I haven't checked it yet, but yeah. Table, no, flux, prompt, image, styles. All right, flux style text gallery. This one I have seen yesterday. It doesn't really help me too much when I looked at it. Winston Churchill one, yeah. 2D game art. Okay, so these are the words, right? Ads sort of movie, but I don't know if are they LoRa's or are they just ads corporate uncategorized? Corporate branding, ads luxury, epic scale. That's another one, right? Okay, so we have given it more freedom now, I think. Photorealistic cinematic shot and focus on eyes, maybe. Focus on eyes. Let's see. All right. So another thing is how to generate these canny images. Those are probably easy. Uh, Python canny edge detection, and OpenCV does it. I saw a little bit of this yesterday. So basically, you have like a script like this, right? And you have an image, and then you just run it, and you have the output. As simple as that. Maybe if we have like a image where we can actually, like, I just want to see if we can do it some sort of these things, like wherein you have like a black image, right, with white strokes, and see if the model kind of does what we want, because it's doing a lot of uh, conditioning scale is very very important because it's giving us a little bit of freedom, right? So this is not a bad shot. I don't think so, especially with photorealistic cinematic shot. Now if I go high, use a bit of higher scale, what happens? All right, so what I'm going to do now is uh I don't know, like maybe I'll draw something quickly by hand and see if the model can do something with this, right? So we need like a black background text, or just we do like this, right? We do like this, fantasy uh child playing a dragon cartoon. Maybe if they have something, images. Okay, okay, we'll check that. Let's see what we got. What did I change? I changed the scale. I should have saved the last one. I made a mistake. Okay. save image as. So as you can see, as we approach towards the end of, like, this thing, end of scaling, then you see that it becomes a little bit of, like, plasticky look. Photorealistic cinematic shot, camera focus on eyes. Travel can miss beach waves. Is it a cinematic shot? That's all. Is it photorealistic? No. Cinematic shot, camera focus on eyes, female travel bloggers, and Christian, blah blah. I think we have to understand where this is not working is okay. Let's see. One of the use cases that I wanted to shoot was photorealistic cinematic shot, camera focus on eyes, female travel blogger with sun-kissed eyes, messy beach waves. Now let's cut all this. Cartoon, 2D, cartoon style, uh, comics, Marvel comics, and see where we go. Probably when we are using this cartoonish style, we can even scale it higher. Meanwhile, here I want a shot that is like this one. Not this, but this one. It's a Shutterstock image. I hope that I get like a decent shot. Now we go copy link address or copy image. Very scared of using this. This is, like, completely opposite to the any sort of license Shutterstock, and I am very careful with creative commons commercial and other licenses. Okay. Why are we seeing Shutterstock again? Maybe we should look for this. Hmm. Okay. I'm going to try this one. This one. Let's give it a shot. How's the image? So we said cartoon style, Marvel comics, female travel blogger, concern style, skin and messy beach waves. How is this? Okay. Uh, okay, this is kind of comic style. 2D cartoon styles. I would say comic, printed comics style, Marvel comics, whatever. We are getting good result, kind of good results at this moment, right? I mean, this looks like a image from a comic, and I want to try something now. I have an image which I want to try. Meanwhile, how do we do this? Open this thing, right? Somewhere we saw OpenCV. This part, right? Okay, fine. Let's do this. Give me a moment and I'll set up a new. Okay, what is this? Okay, I'll set up a new document. This document will be called scanning edge detection. So this will be part of the my notebook repository, but probably I'll not do a blog post on this because there's not much to say here. We need to create a environment, select kernel. I would say I want to create a Python environment, but don't want to create Python environment. Maybe here, Conda environment is better because it stays away from my code base. I like it. And Python 3.11, that's great. Meanwhile, here we go. Did we get anything changed? Printed comic style, that's it. Okay, that's not bad. Half tone is another thing I wanted to put. Half tone. Let's save this model. So this is what I wanted to say. When you have an image, you can always do like these kind of good stuff with control net. So that's not bad at all, not half bad. All right, let's see. We have done this. We need to probably, what is this? Please try. No, this is the old one, I think. If you try to run it, what do we get? We get error. NumPy is not there and all that. We will have to install NumPy. Uh, pip install NumPy. Pandas? No. Matplotlib, CV2, CV2. I don't know if it's called CV2, but let's see. Something is missing, we'll know. What is this? CV from version none. No, I know. It's not CV. It's called something else. Pip open CV. Alright, meanwhile, we'll also check how's the look now. I should have saved the last one. Always make that mistake. Maybe I should set like timestamp or something here. So doesn't do half tone. Is that what is called half tone? Half tone. That's not what it's called. See, this is what I meant. These dots. Maybe I should say comic comics half tone. Printed comic style. Comics half tone. Let's see. Meanwhile, pip install CV Python. Open CV Python. That's what it's called. Got it. On this part, and it's great. So this stream will probably go on till 1 hour, and then we'll do something else. Like maybe from here on, more artwork generations will be happening, and one surprise project will be coming. Like some videos that I will be shooting. I want to really after I do this afternoon thing, hopefully soon. Let's say then we will do some pose, like body poses and things like those, which might be great. The previous one was good. Like half tone is a confusing one, I think, for the model, but I have saved it. It's not bad. Or did I? No, this is the last one. Okay, it's not bad. It's very cartoonish, very good. Printed comic style with half tone dots. Marvel Comics. Now, next thing is definitely poses. I wanted to see from this image. Yeah. So I wanted to run this first. I think it's all installed. Requirement already, blah blah. Okay, fine. Now definitely messy.jpg will not be there. I have to create a new folder which I have to ignore. Dot images, and then here I want to put that image. Let me show you what I mean by the image. Okay. Documents, work. No, just a second. Downloads, Dora Training 2, outputs. I have like this image of my son, which I generated using Lura, and want to see how what we can do with this. So let's see. Dot images slash smiling dot png. File could not be read. Blah 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 blah. Original image PL to show whatever. Plot show. Now how to save this plot also. Wow, it takes that long. Running locally. Wow. Let's see meanwhile where are we with this. Okay. I think half-tone this model thinks is something else and I think is something else. So that's where the major confusion is. Anyways, I think we can live with it. Alright, so edge image CV Canny, what does it do? 100, 200 plot. Okay, if I zoom in, can I zoom in this? No. Original image, politics, whatever. Missing a lot of images, and that's the problem. Not able to detect a lot of images in this. Maybe we can customize some things. Okay. Image, CV Canny, image, edges. Okay. 100, 200. I don't know what is CV Canny. Image is there. Threshold. Threshold 1, threshold 2. What is threshold 1? First threshold for high hysteresis procedure. Don't know. Alright, whatever. I'll just play with the number. I don't want to go into this right now. I'm just kind of sure that first let's see pointer image show subplot image show image cmap edges image show edges. How do I save this thing that comes? Because I want to see the full definition of like as much as I can see. Threshold 1, threshold 2, blah blah. Okay, fine. What do you return? What am I missing something? This is not how you edges. Can you edge detection? There are others also, no? Skylight. Kikit is also good, you know. Psychit. Can you edge detector? Can do that. Okay, this is much better. Why not I try this one, right? What do I need? Key image. So I copy whatever. Those two things. Psychit image. Oh, you have to build and all. First ensure the Python install popular and pip based Python or installer conda based. Skill and via pip. Yeah. Python pip whatever. This one. Install you pip. That's all. Let's do that because OpenCV is great, but I think we can also see what Kyle ski whatever it's called scikit. I will probably check with GPT what it's called. Uh, Alright, so let's see what we can do with this. Copy this whole thing and then we will just run that code separately. New code, paste it, and where's the image? Show image. numpy 0. It's generating from these things. Okay. Capture the canny filter for two values of sigma. Mm-hmm. That's great. How do you push an image? Why do you have to do like this? So many questions. Key get image load image. Maybe it can use below or whatever. Load custom image from file system escaped. Image, yeah. Image img. Right. Are you kidding me? Like, yeah, that's what I thought. It has to come from this. Get rid of this image. All random noise. Gaussian. I don't want all that. Run this. This file is missing. Of course, we know that. Did we get an error yet? No. That means we are still initializing the library. Smiling as gray equal to true. Hmm. Okay, it was fast. And the age detection is great, kind of. When you want to, because see, when you want to do this kind of generation, you want like this kind of really high quality image. How do I export it? IO dot RAM save. This is, we all know who is doing it. Edges one. I like this one more. Smiling edges. Run it. Did we see the image? Yeah, we have it here. Okay, not bad. Copy. Reveal in Finder. And I'm going to upload this in our runtime and see what we can do with this image. So we go here, we drop the image outside. I think we have done CD before. Drop this image somewhere. Go here, and now what? Here. All right, happy. Is smiling edges.png. We also need to do few things before we can do it. Don't want this load image coming from here, but we want to say so one of the ways I think probably everyone knows, load the image using below. No, import. Okay, some things it has got. Paste IO, don't want that. Image dot open, of course, it got it. Smiling edges dot png. Convert RGB. I don't know why it does that. No, we don't have to. Control mode all is fine. Now here we want to say boy holding a football wearing a white football kit. Very excited about this one. Of course, old. What happened now? No such file. Ah, because you're going to the root. Maybe doing like this. Where do we come? Where weight of image expected as input to have three channels, but got only one channel instead. What is wrong? What is wrong in this one? Now, it did say something, right? It said given groups one. It's coming from way deep, definitely. Conf image pipeline. Probably, I think the issue is, I don't know. This moment, I don't know. Let's see. Thousand is fine. What did we do wrong? Come on. Given groups one, weight of size, expected input to have three channels, but got one channel instead. Okay. Convert RGB. Is that what we want to say? Okay, it's generating now. Okay. I think it's complaining because we did not have colors in that image. It was like alpha channel only or something. Excited to see this image now. So the bigger the image is, of course, like the longer it's going to take the image to generate. Let's see what we get. Hmm. Close. Football. Soccer ball, maybe we should say. Increase the. What did we lose in the last prompt? Ball get in a green field. Marble comics. Vibrant colors. Smiling edges is okay. Maybe it has too much details, or maybe it has too less. We have to check and increase this also maybe to 7 and then generate again. Football. Holding a football inside the bracket, maybe we should call it soccer. We'll try that one very soon. Maybe we don't need that high, right? Because we have to first understand what is the output we are getting. And as we get sigma, we start to lose details. Okay, if it goes very high, this is what you will see. So definitely you need to give it some breathing room and give it another shot. Let me have a look at this image. This is definitely Real Madrid, kit. Because we can see from this image also. Okay, we are about to reach the 1 hour mark in our streaming, which is great. But why do we see this kind of weird style? So we have to keep, if we keep it too tight, that's the problem. The model will start to have problems. But how is it, like there are parameters, right, that we can play around with and see how to get this, because what is the mode also is very important. Control image we know, guidance scale we know, how much of the prompt is weight. So maybe playing around with guidance, maybe playing around with control, and what else? Control mode we know. Num image per prompt. From here onwards, it's just basic stuff. Prompt embed, pool, whatever return dict. Okay, so you went higher, and what do we see? If I go even higher, like 9, increase the guidance scale to maybe 4.5 and see. Is this the way to? Mhm. Let's go with depth map, and maybe we'll see what we can do, right? So control net, we are seeing it more. We'll play with more control net. See, get image depth map. Let's do morphology. Python generate depth map from image. Yes, mostly they are using. So what do we see? We are seeing that this image is nowhere close, because my assumption was that using this kind of system you will be able to generate the same or similar image. It is not the same, right? Okay, using a lot of details also. Maybe depth map is the way to go in this situation. Let me see what is this control uh, system will do. Let's have a look at this. Flux one depth control net union. I mean, what do we see? Depth map, what is going on? First of all, gray. Gray is what? They are not even shown it here. So gray pipeline maybe is broken. 0 is the canny. One is tile, which is not shown here. I have to check all of them. Depth, I think this one. So depth is coming from here. There's another one which is kind of different. And essentially the same part. Uh, okay, that's another one. Hmm. You can give multiple control, the same control model. No? To whatever, control net union, flex multi-control net model. That's another one. Diffuser model. I have to see how to do this one. I mean, again, I would consider this experiment to be extremely successful at this moment. You can see that GPU is consistent, we have a big headroom, and we can play around with so many things. All right, so at this moment, I think we can kind of take a break and come back with more ideas. And yeah, thank you for joining, and I'll see you in the next stream. Drop me a like, comment, and subscribe to wherever you are seeing me. Thank you.